Hey everybody, it's Mr. Carr again. Today we're going to be looking at 7.3 day one. We're going to be talking about what's called scatter plots and using what's called linear regression. Now, what is a scatter plot? A scatter plot is a graph that shows the relationship, usually called a correlation between two variables. You got like an X and a Y. In this case, we're looking at average daily temperature versus visitors, total points scored versus number of penalties here. So the other thing we can tell from our scatter plots is kind of like the direction of the correlation. So for example, when you look at this one here, it's mostly going up and to the right. So the idea is that as average daily temperature goes up, number of visitors is going to go up. So that is a positive correlation. And then when you compare that to this one, as total points scored goes up, the number of penalties is going down. So that is going to be a negative correlation. Okay. So positive negative correlation kind of matches up to like what would the slope of a line be that kind of goes through it. So like a trend line going through here, it's trending down and to the right. It's kind of like slope here. Now, correlation does not refer exactly to slope. Um, and we're going to be more specific with correlation with what's called the correlation coefficient here. So correlation coefficient R is a number that's between -1 and 1 that measures the strength of the correlation. So if you are at a +1 or -1 for the correlation, those are both perfect. So we have a perfect positive or perfect negative. Okay. But then there's a wide range of values that can be in between. Now, if you are in the 0.9s, 0.8s, you're up there, you can see how the points are gathered pretty closely together. Same thing with a -0.9 here. Those are going to be strong positive or strong negative correlation. If you get like more spread out with those points, there's not really a good trend line. So like right here at 0, there's relatively zero correlation. And I'll write the word. Relatively zero correlation here. Now, sometimes people will be more specific. They'll say stuff like this. If you're in the 0.5 or -0.5, they might call that moderate. So we could be a little bit more specific with that as well. So we look at these. Does the scatter plot show a positive correlation, a negative correlation, or relatively no correlation? I would say that given those choices, for the first one, I would say that there is relatively no correlation. Okay. And well, no, you know what? This one, when I compare to the other one, I guess, sorry, this one's going to be no correlation here. This one's going to be a negative correlation. Okay. You can kind of see a trend line going through like that one here. Whereas this one, there's not really a trend line on that case. Okay. So I would say this one's the negative correlation here. It's going to be closest to a negative. So R is about a -0.5 because those are pretty spread apart. I wouldn't put that at like a -1 or a -0.9 or anything. When there's relatively no correlation, that means R is approximately equal to 0 at that point. Don't forget, correlation coefficient is not the same as a slope. It tells us the direction if it's a positive or negative slope, but it does not tell us what the slope is. Okay. So if our scatter plot suggests a correlation, we can use our calculators to determine the equation of the best fitting line. So we're going to use tech here for this one. So this is a line that lies as close as possible to all the data points. So once we determine the equation of the best fitting line, we can use it to make our some predictions. This process is what's called a linear regression. Okay. So in this case, I'm going to show you, I'm going to write down the buttons you have to press to get this in a TID4, but I'm going to show you with Desmos how to do this. So first thing is you're going to go to Stat and Edit. Now where this is different from the other statistics stuff we've done, you're actually going to put L1 and L2. You need to fill these in. So L1 will make all these years after 1997. So that's why in the year 1997, I'm going to put a 0 there. And then 1998 is 1 year after the 97, and so on and so on. So your L1 is going to be 0 through 7, and your L2 is going to be these numbers. Do not sort the data. These have to match up. They have to be lined up next to each other in L1 and L2. Okay. After that, you're going to go to Stat. You're going to go to the Calc menu. And you're going to arrow down. I believe it's option number 4, where it says linear regression. Okay. And it looks like y equals a plus bx. Okay. Once you do that, sometimes there's like some extra features in there, but all you really need to do is go down and hit the calculate button or just keep hitting enter until you get there. And that'll spit out some of those values for you. Now, when I do this for Desmos, it's going to look like this. Whoops, wrong one there. There we go. So in Desmos, first of all, I did this. I hit the plus button and you do the table right there. When you do that, you can start putting those in. So I'm going to delete that one out because I already put the data in there. So under X1, I've got my years since 97. My Y1 is all the numbers there. A nice feature about this is if I hit the magnifying glass, or magnifying lens there, it's does a zoom fit and it shows you the window that's like fitting to our statistics there. From there, a nice feature of Desmos now is if you look in the upper part of the right by the number 1 here, this will pull up our regression. And it's automatically going to be a linear regression from that one. Okay. And then if you want to see a little bit more here, it just plotted the line for me as well. Okay. So it does my linear regression. The other important number that you can tell from here is R. R is a 0.993. That's a really good, strong correlation there. Okay. And yeah, that's it right there. So I'm going to go ahead and write this down. So 40.87x plus 262.8. So y equals 40.87x plus 262.8. So now, using this information, I'm going to use it to make predictions. If these trends continue, use your equation to predict the number of hybrid vehicles that will be in use in the US in the year 2020. Okay, so the idea is that in the year 2020, since we define this as years since 1997, I got to figure out what year is 2020 compared to 1997. So X is going to be 23 when we compare those. So all I have to do is just plug this into my model. Y is equal to 40.87 times 23 plus 262.8. Because remember, this is X is the number of years since 1997. And then Y is representing the number of vehicles. Okay. The number in thousands of hybrid vehicles in use in America. So we plug this in the calculator, and that's going to give me about 1,203. In this case, it's going to be 1,000 cars. So 203,000 cars. Now, more realistically, I wouldn't write it that way. So I would do 1,203,000,000,000. Okay. Oh, wait, sorry. One second here. Sorry, I just had to double check the calculator. Yeah. So that is 1,203,000. So it's 1,000, it's 1,203 thousands, which is over a million there. Okay. So in the year 2020, we would expect there to be that many vehicles that were hybrids. Okay. And that is it for today. So we just talked about our trend, like talked a little bit about our trend lines, but really focusing on the scatter plot. What is correlation? And how can we do a line of best fit to our data that we show on there? All right. But that's it for today. So take care, everyone.